Hello Internet, this is Tom Rowe, 411 Vids, and I thought I'd get started a little early this morning. I've got to head off to work in a little bit, but before I went I thought I'd go ahead and create this short video. Something I wanted to cover today is the Lunar Reconnaissance Orbiter, I think that's what it's called, and the Lunar Crater Observation and Sensing Satellite, LCROSS, were launched on an Atlas V rocket on June 18, 2009. And they took their 4-day trip to the moon and spent 3 years in low orbit collecting detailed information about the moon and its environment. After the initial orbit, LRO transitioned to a stable elliptical orbit, passing low over the lunar south pole with a suite of 7 powerful instruments, and it has collected a treasure trove of data, making an invaluable contribution to our knowledge about the moon. So if we go back to June 18th of 2009, we put 3 days or 4 days later, we put a satellite in orbit of the moon. Now, some of you may have known this, some of you didn't. I would suspect there are more than one satellites orbiting the moon, mapping its surface and taking photographs of all the details. So the thing that gets me about this is when I did some basic research on the LRO, I was curious about whether it had a color camera, because when we see pictures of the moon, they're always bleak. They're always dark gray, like somebody tipped over their barbecue grill and all the gray ash just dumped out on the ground, and that's what we're walking around in when we visited the moon back in the 60s. That, you know, it's bleak. The only color you'd see in those images from the Apollo missions was the color of the flag, or maybe a device that they had brought with them. And so I just wanted to review what the LRO had done and see if maybe they had a color camera on board that they could show us something a little less bleak about what the moon looks like. Okay, so you've had this thing orbiting the moon for years and taking photos and scanning the surface, and so you're probably thinking that, well, we must have some really cool images of the moon. I mean, we've got a satellite a few thousand feet above the moon just going around it constantly. There must be some great images of the lunar surface. Well, before I go down the conspiracy path, I want you to go on a little journey with me that I went on earlier, where I was exploring the possibility of color moon images from recent years rather than the ones we got from way back in the 60s and 70s, and see if we could get a better look at the moon than those old black and white photos that we used to have. So let me go ahead and do this switch over. Okay, so here is the website for the LRO mission overview, and it's 7 powerful instruments. Here's where it says it was launched on June 18th, 2009. Let me see if I can zoom in a little. Nah, I don't want to do that much. That's good. All right, so if we go back to this page, it lists all of the LRO spacecraft instruments. So we've got this cosmic ray telescope, a Diviner lunar radiometer experiment, Lyman Alpha mapping project, lunar exploration neutron detector, lunar orbiter laser altimeter, Lunar Reconnaissance Orbiter Camera. Now we're getting into something. So we've got two narrow angle cameras on the Lunar Reconnaissance Orbiter Camera. LROC will make high resolution black and white images of the surface, capturing images of the poles with resolutions down to 1 meter or about 3.3 feet. So when they say resolutions down to 1 meter, they're talking about square. So I mean, when you look at a pixel in one of their images, you're looking at about a meter. So that pixel is a meter. So you know, you're not going to see a rodent running across the surface of the moon, because the smallest thing you could see is a rock about 3.3 feet by 3.3 feet in size. So smaller things will be lost, which is, it's understandable. There's a lot of data to collect, and you can only get so fine a resolution on those cameras. So then we go to the color and ultraviolet images taken by a third wide-angle camera, the WAC. They'll cover the complete lunar surface at 100-meter resolution. So when we get color images from the moon, we really go low res. I mean, we're going from 1 meter per pixel to 100 meters or 330 feet per pixel. And I don't want to use the word hide in a conspiratorial way, but if there was a sequoia tree sitting in a valley on the moon, this camera would not be able to see it. I may be exaggerating slightly. I mean, sequoias are, many hundreds of feet tall sometimes. Well, yeah. So you might see a sequoia, but you're certainly not going to see any shrubberies. You're not going to see, am I saying there's foliage on the moon? I don't know. Is there an atmosphere on the moon? I don't know. We sent a satellite up just a few years ago, and we put a camera on it that can only see a pixel as a 330-foot square block. You could lay a 33-story building down on its side, and this camera wouldn't know the difference from it and a rock. So, I can't help but be a little skeptical and cynical about the NASA space program when the technology they're sending up there to give us eyes in the sky so that we can look at the moon are so low resolution and low capable. I mean, can't they even zoom in? Maybe at maximum wide angle it's 100-meter square pixel, but why not be able to zoom in so that you could get a look at something a little closer? Optical zoom. I mean, I have this little camera here. It's a Canon with a 53 times zoom. So, you could zoom in. And they say there's no atmosphere at all on the moon. I'm inclined to believe them. I don't have a lot of solid evidence of an atmosphere. So without an atmosphere, you don't get that distortion that you get when you're trying to look at the moon from the surface of the Earth. So when we're looking with even a really good telescope from the Earth, we're having to look through our atmosphere. And that creates a wave distortion that looks like a heat wave on the desert or something. So you can't really get a lot of detail from the surface of the Earth. So I was excited to know that we had sent a satellite with a camera right to the moon so that we could get a really close look at it. Excuse me. But come to find out that we're only able to see a 330-foot block of color. You know, and I can't stress that enough. It just doesn't make any sense. In the 50s, we were able to use our satellite technology to pick out very small details on the ground. Back then it was film and infrared and stuff, but we've come a long way since then. And so it just kind of boggles my mind to think that we send $1 billion spacecraft, you know, or $500 million, whatever it was, to orbit the moon for years, and the technology that we put on board isn't even up to the cell phone cameras of the time it was launched. Well, maybe I might be exaggerating just a little bit there, because so it was launched in 2009, and the best cell phone 2009. So iPhone was out, the LG Dare, the Samsung Behold. You know, it wasn't great, but it wasn't awful. And so I just feel like, you know, it's the military, it's the government. They probably got better technology than we had in our cell phone cameras at the time. And yet when we go to all the trouble to send a satellite to orbit the moon, we get back pictures with a pixel resolution of 330 square feet. So what does that give us? Well, I found this video, and so I'm going to play a little bit of that for you. CGI of moon based on real LRO data. So this scanning technology is capable of picking out these amazing details. Little rocks, well, they're probably not little, they're boulders, but all that detail, and yet you'll notice something is missing from these images. First of all, they're not photos. That is, I think, that's a photo. All right. But when we do an actual flyby look of the terrain, what you're actually seeing is, I think that's a photo. That looks pretty good, but it's black and white. It's grayscale. That is the Earth. So we look at that and we go, you know, we can tell what's going on in this image because you know, we see green, we know it's foliage. We see blue, or reflection, we think it's liquid or metal. You know, we pick up a lot of the details based on the visual cues that are contained within the image, and so you could figure out what's going on here because you're comfortable with it. But we go back just a little bit here, and in this image, you know, oh, it's the moon. It's the same moon we saw back in the 60s. So, does that give anyone else pause? I mean, does that make you wonder, you know, what the heck? Why are you not showing us color images of the moon? Well, if we go back over here to their website and we go to the images section, you could see that, oh, well, there's some color. Look at that. So we have this image of Earthrise that's an updated image from one of the Apollo missions, which had a really fuzzy, blobby version of the Earth taken back then with a handheld camera from one of the Apollo crew. And if you go to the View Image feature and you start reading through this, you discover that this is not a photograph. It's a composition of multiple images. And even though the LRO experiences 12 Earthrises every day, when you go back to the images, you never see an image of Earthrise that is not a composition, something that's been manipulated in a graphics application. Okay. All of the images of the moon are gray, except for this elevation data image, which is just there to show height. Okay. It's very frustrating to me. We see in color. Some of us dream in color. And we spend billions of dollars on technology to give us eyes in other places that we can't get to. And then they send back these images. And there's not a single live color image of the moon's surface here. Now if we keep exploring, and you do a simple search, oops, let's see here. If you go to Google and you type in if you type in color photos from LRO on Google, you get that quote-unquote iconic image. That's a composition. It's a manipulated image. And then you get this one with some color in it. And you're thinking, wow, that's interesting. That's way more interesting than a grayscale image. So let's go check that out. So let's view this file. We'll just save that here. And now let's open a color or an editing program, and we'll just open that file up. Okay, so we can zoom in on that. We can see there's definitely something going on here. And this is what the moon looks like. Okay? This is what the moon looks like. It's beautiful. It looks like it's covered in gemstones. The samples we brought back from the moon have massive amounts of titanium and other interesting things going on in those minerals. The moon is a treasure trove of material, and yet when you look at images sent back by NASA, most of them are gray. Now, I can enhance this a little more. Wonder what's going on here. I can go to image, let's see, filter, adjust, HSV. Okay, just saturate it a little more. So we got some blue here. Got some red, blue, yellow, green. You go over here, we've got this beautiful red and some blues and greens hidden in there as well. We got some blue in here. It looks like diamonds Also, when you grayscale an image, you lose details like this path here. You know, there's a whole lot of stuff going on here. It's absolutely gorgeous, but we never get to see it except occasionally when something like this comes out. And so I can't help but be cynical about the government space program and what they're willing to share with us. If I keep going, I get the specs on the camera so I could find out what else is contained there. You can look up like this image here, and you could see that this image was actually taken from a ground-based telescope. So somebody has to get through the atmosphere of the Earth, and I'll show you some video in a second that just shows how horrible that is. I mean, it's not horrible, it's great, because they have to spend a lot of money, many thousands of dollars, just to get an image like this. And you know, this has probably been processed a little bit in Photoshop or something, but look at that. It's gorgeous. I mean, it's like a precious stone. And I can't help but be annoyed. I want to keep my videos positive, but they're really annoying me. And I think they're annoying a lot of people, because we have invested trillions of dollars in our best scientists and technologies to bring back information. And the people sitting on the ground with telescopes in their backyard are able to give us better images than we're getting from those trillions of dollars of investment. So I'm sorry, that's just not going to cut it anymore. They're going to have to start providing us some value for our investment. And as I mentioned in a few videos back, this Space Force movement, I think, is just an opportunity for the government to start rolling out some things that they've been keeping from us. So, how the Earth's atmosphere removes saturation color in photographs. I don't know if you realize this, but if you're looking at a scene like this, right? And let me open this in another tab. As you can see, the more atmosphere between you, your camera, and the what you're looking at, the less color you get. So you can imagine on the moon, when we're quite a ways away here on Earth and we're looking at the moon through our atmosphere, that the colors are muted, you know. They're horribly muted, like that. So here's a camera sitting on the ground, and in the foreground you see all these rich reds and some greens and blue, but back here it goes to gray, and the greens are washed out and the reds are washed out, and the sky is even almost gray. You see? And I think that's something that I want to help us do, is to see. When something comes to you from the government, look at it. Be objective. When they show you lunar photos and it's all gray and bleak, and yet some guy on the ground with a telescope in his backyard can show you color, even through our atmosphere, you gotta wonder what they're hiding. And they're hiding a great deal. So I just wanted to bring this to your attention. You know, here's some shots from Apollo. You know they're using color to get these photos, because when you look at some of them, you have color in the image, right? But this looks like, you know, volcanic ash. I mean, it's not even as interesting as volcanic ash. So it just, it makes me wonder. It makes me wonder what the heck's going on. And so we go here and we see some color in that, but the ground is just bleak. And maybe in this area where they landed, the ground was bleak. You know, they were looking for a boring place to land because they didn't want to damage the vehicle. I mean, they only have one engine. They only have one shot at getting back off the surface and getting back to Earth, you know. So I understand, you know, wanting to be cautious back then. But when we're sending robotic satellites to orbit the planet, we ought to be able to get more. We ought to be able to get more information, more color. That we ought to be able to see what it really looks like. And I'm not even going to get into the fact that there are no stars. Because I know, as a photographer, that when a camera is trying to bring this white to a level where it's not completely a block of white and completely washed out, that more subtle lights, like the stars in the sky, are going to be lost into the darkness. You know, in order to get this gradient range, you know, you're probably going to lose the stars. So I'm taken back to a trip in 1989 where I was traveling across the country with my wife and my daughter, my only daughter of the time. Now I have 3. And we were heading from Kentucky through Texas, and then we went on to California, where we were going to drop off our truck so that it could be shipped over to the Philippines, and we could pick it up there, because we were my wife Robin was active duty, and she got orders, permanent PCS orders to the Philippines. We were going to be over there for a couple of years, and I was not active duty at the time, though I had served prior to that. And we were driving across the mountains in Utah, and they were doing construction. There was no lights up on top of the mountain. We happened to be going over on a crystal clear night, and I had to stop the truck because there wasn't a lot of traffic, and they were doing construction, like building new road or something. And I had just glanced, you know, I'd looked up through my windshield, and I noticed that the stars were really brilliant. And so I pulled off the road and I turned off the lights, and I got out, and my wife was like, "What are you doing?" And I had to go and check this out, because I'd grown, even though I'd grown up in the country a little bit, where we didn't have a lot of light pollution, I'd never seen stars like that. And it was really high up, so I guess there was less atmosphere. It was just a clear night. There was no clouds. And so I got away from the road because I didn't want any cars lighting anything around me, and just stared up at the sky for like 5 minutes. And what I saw was not like this, because there was no snow, but it was stunning to me. You know, it was the galaxy, the Milky Way, and the sky was just packed with stars, and I'd never seen that before in my life. This is 1989, so 25 years old. So 25 years old. And I have never seen anything quite like it since. And I ended up questioning the Apollo missions because at one point I remember seeing reports and watching video where we lost contact with the I can't remember what it's called, but the thing that the lunar module attaches to, and they were going around the moon. And so when they went on the far side of the moon, which was dark at the time because the light side was facing us, we were going to be out of contact. And I thought in my mind, which is where I do most of my thinking, I thought, man, if being up on a mountain was that beautiful, looking at the sky, what would it be like to be on the dark side of the moon with no sunlight and looking up at the galaxy with no atmosphere, nothing between you and the stars? It would just be majestic. It would be just God's universe laid out before you. And yet, during the interviews after that mission, the astronauts don't mention it. They don't talk about the stars. I even remember one astronaut saying he didn't remember even seeing the stars. That boggles my mind. I can't believe it. I really, literally can't believe it. You can't possibly be in a situation like that and not be just gobsmacked by the beauty of it and have to talk about it when you return. So you're going to have to draw your own conclusions. This video has run on longer than I expected, so I'm going to go ahead and stop. But I hope that you found this intriguing and a good start to your Tuesday, January 8th, 2019. I look forward to seeing you in the next video. You have an amazing day. Bye-bye.